Okay, welcome to the second part of this tutorial series. When we left off with the setting up of the project, a couple of things I forgot to do. First one is obviously we need to start it. So let's run it and see if our skeleton project works. We have added a dependencies. I have added a dependency, so it may not work anymore. And actually, I can expect it not to work. So what's going on? Yeah, it takes a little bit of time. Right? So we have a couple errors. One error is because the library that uses the camera, the QR code scanner, depends on the Android level 18 at the minimum. So you have to go to Android app and then this Gradle file and bump up the version of so 16 is not, it has to be 18. So bump up is 1 to 18. Okay, and the second thing is we are going to connect to the internet. So for Android, we have to use to have a minimum of permissions. I think it's Android manifest. So in that file, Android manifest, we have to add the permission. Android app source main this permission connection to the internet. So you put it down there. So yeah, internet here, and we can rebuild. Okay, so a few warnings. That's in this library share preferences. That should not prevent us from running the app. Okay, at this point you should see the classic app on your screen. Right. This is the demo guy. All right, so next step now is to do some integration with Rust. So I'll stop this guy and stop this guy. And what we are going to work on is the Rust library. So we can close this one and go to native. So this package here, Z3 Rust, Z3. I've checked in the project on GitHub, so we can take a look at this guy and specifically the branch light for our light wallet. So there are 3 commits that are being made. You can see them here. I think this is history. So I made these 3 commits. These are not very big changes. The reason why we need these guys is this guy here, the normal guy. You can see that it uses well, I did a few functions like has a count, but mostly it's because init account before didn't take the directory path for the database and kind of always put the database in the current directory. On mobile, the current directory of the application is actually not writable by the application, so this would fail. Instead, the mobile app has to query for the database directory path, and then we have to pass it to the library so that it will create that database in that directory. So this is the only really major thing I would say that has been done. So every time you have a function like this that requires a database, we need to pass a directory path so that the data path is made by the concatenation of the directory path and the base path. So that's the change. The other change is that the command line utility was simply printing the values on the console, just like this, balance is print, but was not returning anything. So since we now need to do the UI from the application, we need to return the value as well from the function. So not very major changes for this one. The other one here is I just added a function to check the address. So this function uses is when you send something to somebody, you send some coins to somebody, we're gonna use this function to make sure that the address is valid. So to do that, we use the decode function in Rust, which then returns OK or not OK. And the final change is the fact that in the command line utility, we can read the curve, the zk doc parameters from a file that is located in zc params. So normally you would have downloaded these parameters and you would have stored them in the local in that directory .zc params. But again, from a mobile phone, that's not going to be available there. So we would need to pass these parameters through the bridge from Dart to C, and we need another function for that. So I added this function sign transaction with bytes, which works the same way as sign transaction, but the prover is created from bytes that are passed as parameters. These send parameters and these output parameters would come from Dart, and then we call the regular sign transaction. That's the other change. And the final little change here, and this check-in, this comment, is the fact that I have also reduced the target the anchor. So when you create a transaction, you need to specify an anchor for the spending part. Anchor is a block where you know that these spending coins are happening before. Normally, for privacy, this anchor is chosen 10 blocks before the current block. So if, for example, you're targeting the block 1010, so the next block is 1010, the anchor would be 1000. In order for us to be more responsive, we don't want the user to wait for 10 blocks before being able to spend their coins. This has been reduced to 1 block. So you can essentially spend the block, the coins right away, as soon as this has been mined. This is one change. So the changes before do not change the functionality or the behavior of the normal code path. So technically, we could have included them in the main line, but this one is actually changes the semantics of the application. So I'm reserving that guy to this light branch. The main branch actually stops here. So now that we have made these changes, these commits, we are going to point the branch ZC3. So this one, we're going to say we are checking out this particular commit point. We can say light. What are we doing? What? Why is that not working? Oh, I have to fetch first. Okay. So by doing that, we have associated our submodule to a particular commit point, and I'm gonna check in this point. Okay, right. So okay, so this is check-in. So now we can move on to the next step, really, which is using this stuff. So how to use this native code? Well, you need to have a bridge. This is not going to be called directly from Dart. This is not possible to call directly from Dart. You have to call as a C, export as a C function. So we have actually another module which goes here. It's the C API FFI. For FFI is foreign interface, but what is the F? I forgot. For FFI. Foreign function interface. Okay. And so let's create this module. So here, and then we go to native, and we create another library called ZC API FFI. So it's new. Right. So actually, this guy didn't do much for us. He just created cargo and the lib file, and this cargo doesn't have anything. So what should it have? So you can see the difference between that one and this one. This one is same here. So we have to add the dependency between to the previous package. So that's this guy here says that our package obviously depends on the package ZC for this particular path. And then we have a couple of other things here. Right? So this I'm just gonna copy it for the moment and tell you what it is. Anyhow is error library. Sokyo is the executor. So we need this one because the functions in the main package in ZC they are synchronous. This is okay from the main. We're not going to use the main from ZC from the Rust ZC. We are going to use it as a library. So we need to call the async functions, and the Dart side would be blocking in order to avoid complication with callbacks and threads. So we need Tokyo to be the executor for async functions, and these two last guys are the loggers so that we can debug a little bit. And finally, these build dependencies here is going to help us create the bindings between our Rust side and our Flutter side. So this is all you need here as dependencies. So let's go to this guy and then make sure that we can actually build. All this building is cargo build is done on Linux. So it's done on a platform that is not the one from the phone. So actually, this is not really meaningful. This is not the code that's going to be used by the phone. But because the Rust is quite portable, by compiling on your PC, you already have a good idea whether it's going to compile for your phone. And this is much faster to compile on PC than to compile on the phone. All right, so we have a bunch of unused functions, and that's mostly because when we use from Rust, as a library, we're not using the main this guy here, right? So some of this stuff is currently not touched. All right, so let's go now and then edit the lib file. So the lib file is actually your entry point for this library. So what we have here is simply the import of these three files. We have account, FF5, and init. So I'm also copying these files over. Right, and then we can take a look at these files. Right. So let's see. First one is account. So we have a couple of functions. Let's see the easy one. Get balance. So that's the function what we are going to call from Dart. and how we bridge it to the Rust side. So what we do here is call the get balance from our library. So this guy, Zcash code wallet, is ZC, and account is the module account. So in there, there's a function called get balance, which takes the directory path, and we are calling it with asking it for the balance. If we have, so the all these functions, all these functions here, they return a result, which is this guy here, right? A combination of error or OK. If it's an error, we can't really send this error away around from because they have different types. This function, when we export it as a C function, we have a unique return type, which is in this case a number, an integer. So if we have an error, well, we're gonna return 0. Otherwise, we return the value. So this is how you do one of the bridge. And this is a simple case. When the case is more complicated, for example, we have a function here that does synchronization between. So sync is where you will download some blocks from the Light wallet D and put them into your database. So all this stuff is done on the Rust side. Right? Again, we only have one return value, which is the number of blocks that have been synchronized. And the inner function that you want to use is this guy, chain. So chain was imported here, right? So that means this is a function from ZC chain sync. So that function should be inside here. This function is asynchronous, so it needs to be run by executor, which is a runtime in Tokyo. So this is basically a thread runtime. So we run that async function, and we are blocking on it. This is boilerplate for the most part. And then again, if we have an error, we turn this error into a value. So you could see we could, as demo, it's not super important, but ideally you would return a type that also expresses that there's an error. So when we return 0, it's not a very good value, because 0 is actually a possible return. It is when synchronization finishes, it will return 0. So we should be returning like -1, but as a U64, -1 is not possible. So we should have I64 and return -1, and set the error into some global variable that we can query afterwards from Dart. But here I'm just returning 0, and I'm logging the error. And this code here is whether if this code panics, I'm logging as a panic. So actually panic should not happen. This code here actually is not needed. I put it there because at that point I had some more serious errors. So I actually remove this. Let's put it, make something easier. Let's make it just like that. Then there is something. Why do we have a parenthesis? Say unmatched. Yeah, so that should be match. Yeah. Still not okay. What do we want here? Parentheses, this guy matches this guy matches this guy, this parenthesis is useless. Right, this is a function now. And so every time you have an async function, so for example send, this is a function that is exported that we're going to call from the mobile side. And you can see that it takes these spending parameters as a series of bytes, but it's calling an async function. So this is going to wrap the async function into a blocking call. And the async function is actually here, where we do a simple combination of prepare, sign with the transaction, sign the transaction and submit it. Um, so the pattern is always the same. So you gotta have all these guys the same here. Init is also very similar, where we have async init, a init account async, and we make this guy synchronous by wrapping it inside a runtime. I think actually that one way to even make it simpler is to create a macro for this, but I didn't do it. And finally, these functions are still Rust functions, so you need to have them as C functions. So FFI here is the final piece of the puzzle, where we export a C function with that name. We have to put no mangle so that it doesn't add the Rust mangling for the function names. And now the parameters are C-type parameters. So you can see here that we are not taking a string. We're taking a mutable pointer on C chars. And here, since these are null terminated characters and no longer Unicode or UTF-8, you have to do a little bit of conversion to convert from that C characters into a Rust string. But again, this is really mechanical. So strings will be converted like this on the way in, and like this on the way out. So there are two helpers for this: C string, which is an immutable C string, and C string, which is a mutable string. So that's the entire logic for the bindings. Okay, so now we have all done this. We can try again to compile, and you can see that that compilation also worked. Right. Let me double sure that it worked. Yeah. So how do we call this? So this is not completely everything, because currently the project, this project here, is only a pure Rust project, and it's only compiled on your PC. So you want to actually compile this for the different architectures of your phone. Another thing that we need to do before is copying this build script. So we copy it here, and we take a look at what it does. So what it does, so this is actually copied, I got this from another project. I forgot the name of the project, sorry about that. What it does is it will create it will auto-generate the bindings for, so this file here is auto-generated by using a tool that scans your Rust files for external C functions, and it creates a header file that has the proper signatures. So all the functions that are here, for example, that mark no mangle external C, will be scanned, and it will create this file binding.h, this header file, a C header file. And the second thing it does is this build script is creating this dot binding file. Sorry, here this dot binding file, which will be in the in our package directory. So right here you don't have anything here yet, right? But once I have imported this build script, and I run build again, okay, this would have generated binding.h, right, which has all the C declarations, and also generate this file fi.dot, which is the bindings for the dot side. And this file here is where all the FFI is produced for the dot library. So we can go now here to this guy that was also automatically generated and add the binding on the dot side. So I have done this. So I just need to copy this guy over. Right. So let's take a look at this. Let's take a look at this logic here. The zigzag here means that we are missing FFI, right? So I must have forgotten to add FFI. So FFI. This is the FFI library for Dart. So we need to add it here. Pubget. And now this should be fine. Okay, so what do we have? All the functions that we have exported from Rust will be available under this this package, because we are importing ffi.dart, which was automatically generated, and we name it ZCFFI. So now ZCFFI init account, for example, is going to refer to the init account from the share library, that is the C share library, basically produced from Rust. So whenever we call ZCFFI, we're actually calling into Rust. And therefore, again, we have to convert the strings, which are UTF-8 in Dart, into a C string of characters. So the same way that we are doing this dance of converting strings from C to the Rust, now we have to convert from Dart to C. So strings have to go from Dart to C and C to Rust, and same thing on the other way. So this is only a fairly tedious thing, but it's not really difficult because we also have a helper library in this FFI guy, which provides a function from UTF-8 and to UTF-8. Other things like primitive types like double integers, they don't need to be converted. The other tricky one is byte data. Byte data has to be copied, and you will see some logic here to copy the byte buffer from Dart into a C buffer. So it's not very interesting, but it has to be done. Then this exposes all these functions as static method on this package ZC API. So now the bridge is done, right? So now that we have this, we can call from Dart into Rust all these functions: initialize, init count, sync, get balance, and send. So these are all the functions we need for our wallet. So let's make sure that this still works, and for this we are just gonna run the project. Let's check that this is also done, used here. Yeah, our package is used. So at this point, the entire chain is completed, and the rest will be about making the UI and using these functions. Okay, so I can see the whole application on the phone. Right? So this compiles fine. Yeah, this is running on my phone. All right, so this concludes the second part. So we have done the Rust integration. So we'll save this stuff. Okay, if it's long, it means that we have something that we should not have checked in. Let's see. This is probably inside this guy. Package. I don't know why. I try to check in the target files. So Okay, let's make sure we're not checking anything we should not. These are all source files, so that should be fine. And that's our Rust integration bridge. And push. Okay, so this is the end of the second part. In the third part, we are going to do the UI.